Okay, so we're just going to add on to what we just learned about use substitution and apply it to definite integrals. So I kept on saying integrals, but before we were working with indefinite, which means that there were no bounds with the integral. So now we're going to work with something with bounds. So it's going to have like a little number on top. Let's say it's 1 and then 2. These are bounds, 1 to 2. So this time, instead of writing C, we'll plug in the upper and lower limits, just like any definite integral. But we have a choice. We can change the limits to match U, or plug the x expression at the end. So I'll show you in a cleaner way. So change the limits to match U is actually the better way. So remember, you want to pick U, find a U, change the bounds, rewrite the entire integral in terms of U, integrate. Lastly, you want to evaluate the definite integral using the new U limits. So I said that pretty fast. It's okay. We're just gonna work it out. So we're just going to be 2, 0, 2x plus 1, 3, 2 dx. Okay, so I'm gonna choose my u. Again, 7 in parentheses. This will be 2x plus 1. And then, yeah, you can be happy and follow in. So you can just do du dx equals 2, really. And, yeah. Sorry, I'm distracted. Times dx. Oh, and look at that. They both match. So that means this can be replaced with just du. Okay, so 2dx is already there, so we're good. Step 2, we want to change our bounds. So this is our original bounds, 2, 0. However, we can replace 2, 0 with our original function 1. Let's originally do u. So when x equals 0, u is just going to be 2, 0 plus 1. That equals 1. Okay. And then when x equals 2, u is just going to be u. Second, well, u 2 plus 1 equals 5. So where were these? So this is just going to be placed up here. And this is going to be placed up here. So then our new bound is 5, 1, u, there. And now my favorite thing I want to do, I want to integrate this. So what I'm going to do something that's going to grow a little bit better. So we get to the fourth, so we're going to take the antiderivative like usual. But then we want to substitute. So what we can do, we're going to use our bounds for this too. So I to the fourth minus our other bound is 1 to the fourth, but about 4. And then just subtract it. So 5 to the fourth is 625. And then 1 to the fourth is just 1 divided by 4. Then it's going to be 624. There's 4. It's going to be 156. And yeah, that's our answer. Oh, that's 150. It's 156 if you simplify it. So let's do example 2. We are going to make our lives a little harder. And we are going to use the square root. Okay, so we're going to do 3 squared 5x squared plus 3 times 10x dx. Again, we're just going to do what's inside the u, which is just 5x squared plus 3 du, then it's 2 squared 10x dx right here. So try 5 dx. Oh, look at these both match. So then this can be replaced with du. And so now Yeah, so now we're ready to further everything more. So our original bounds were 3 and 1, but this is how like the chances we're going to replace this for u original function. So when x equals 1, so then that's just going to be 5, 1 to the second. Yes, 30, which is going to be 8. And then when we have x equals 3, which is our upper bound, we're going to do 5. Kind of simplify it. So, like 5, 9, plus 3 equals 48. So then you want to rewrite this and then integrate. Be 48 to the 8th. You 1/2. So remember, we're still dealing with the square root. So then it just changed it. Du. And this is just going to equal 2/3 u 3/2. And then we're gonna do this line. But if you do like this bar, you just wanna use it to substitute it. So then now with our final act, we need 2/3, and it's just gonna be 48. And then over that, and then minus 0.2. Oh, yeah, over 2. And then it's going to be 2/3. And then it's just going to be this 48 radical minus radical 8. Don't forget the parentheses, please. And then all of that is just going to equal, honestly, you can kind of leave it like this. Or you can plug in the decimal. Either way, the steps are correct. So, if you want to go more in depth, you can do like you have like 4. Yeah, you can just leave it like this. Not really. Let's do example 3. We're going to do bounds 1, 0. We're going to do 8x. X squared plus 4. Which is 2 dx. And then I'm going to pick our u. Yeah, pick our u. This isn't 2, but okay. X squared plus 4 squared. And then we are going to do. Oh, wait. This is so. It's just 2x, sorry guys. It's 4. And then it's just going to be 2x x. So, makes our lives a little bit more complicated is the fact that this doesn't really match up. So we don't have. So we have dx right here. I'm going to go even further. It's going to be 2x right here. So du dx, 2x. So then, now we have our original equation, which is like this. So then it's 1, 0, 8x under u squared. And then what we can do here, we can take, since this is du, 4x, these can divide. So that's just going to give us 2. So then we're just going to put 2 out here. Right? Well, no. Right? Divided by 4. Actually, going to be. Oh, well. Is it not going to be 4? Oh, yeah. Okay, sorry. Okay, du. So we got 8x in the integral. It's going to be 4x. Well, it's going to be 2x. Yeah, it's going to be 2. Sorry. Du, 5. Personally, I would write it like this. But that's just.